Hey everyone! Today we're going to dig into something that seems simple but literally built the world we live in, boiling water. Seriously, we're going to explore how that simple process created the raw elemental force of steam power.
I mean, just think about it for a second. We've all seen these incredible, massive steam locomotives. How in the world can simple water vapor, steam, generate enough brute force to move hundreds of tons of solid steel? It feels like magic, right? Well, let's get into it.
It all really boils down to one simple idea: turning heat into motion. See, when water becomes steam, it expands. And I mean it really expands, with incredible force. The secret isn't just making steam, it's about trapping it, containing it, and building up immense pressure.
Okay, so the beating heart of this whole operation is the boiler. Its job is pretty straightforward: heat up water until it turns into steam. The key, though, is that it does this inside a super strong sealed container. This allows the pressure to build and build and build. That high-pressure steam is basically our fuel. It's stored energy like a coiled spring just waiting to be released. All right, so we've got this tank full of high-pressure steam. Now what? The next challenge is turning all that pent-up power into actual movement. And to understand that, we've got to look inside the real heart of the machine, the piston engine.
The key to this entire thing is a concept called reciprocating motion. Now, that sounds super technical, I know, but all it really means is a simple, repetitive back-and-forth movement. This is how the engine takes that invisible force of steam and translates it into the hard work of turning giant wheels.
This is where the magic really happens, in what you could call a rhythmic dance. A clever valve shoots high-pressure steam into one side of a cylinder, which violently pushes a piston. Then, the valve shifts. It lets that used steam out, and that's the first CHOO. While at the exact same time, it shoots fresh steam into the other side of the cylinder, pushing the piston back the other way. Another shift, another release, and you get the second CHOO. It's this constant, powerful push-pull cycle that creates both that iconic sound and the relentless force that moves the train.
But, a machine this elegant didn't just appear out of thin air. It wasn't some single flash of genius. It was the result of decades of trial and error, with brilliant people building on each other's work, step by step, to perfect the design.
Really, the whole story of steam power is a story of solving problems. It kicked off way back in 1712 with Thomas Newcomen. His engine was pretty crude, but it did one job really well: pumping water out of flooded mines. Then, decades later, James Watt came along and had a breakthrough idea: the separate condenser, which made the engine dramatically more efficient. And finally, in 1804, Richard Trevithick took that more efficient engine, figured out how to make it high pressure, and put the whole thing on wheels. And just like that, the steam locomotive was born.
And this is the real game changer. The steam engine wasn't just another clever invention. It was the technology that kicked off an entirely new age for humanity. For the first time ever, we had a source of power that wasn't tied to the strength of a person or an animal or the location of a windy hill or a fast-flowing river.
All of a sudden, you could build a factory anywhere you wanted. You could move tons of goods across the country at speeds that were just unimaginable before. You could cross an entire ocean without ever needing to wait for the wind. It was, in every sense of the word, the engine that powered the Industrial Revolution.
It is truly impossible to overstate the impact this had. As the quote says, steam power wasn't just part of the Industrial Revolution, it was the driving force. This one technology completely rewired society, from the economy to how we think about distance and time.
Now you might be thinking, okay, steam trains, old-timey stuff, that whole era ended with diesel engines, right? Well, here's the twist. The age of steam never actually ended, it just got a whole lot quieter, and it's hidden in plain sight all around us.
See, the modern steam engine is a different beast. Instead of pushing a piston back and forth, a modern steam turbine uses focused jets of steam to spin a set of blades at incredibly high speeds. Imagine a pinwheel caught in a hurricane. This super fast spinning motion isn't great for pulling a train, but you know what it's absolutely perfect for? Generating electricity.
And this is where the story gets just absolutely mind-blowing. Around 80%, let that sink in, 80% of all the electricity generated on planet Earth comes from steam turbines. Yeah, the lights on in your room right now, the device you're watching this on, there's a very good chance it's all being powered by steam.
Sure, the way we make the heat has changed. We're burning natural gas or using nuclear fission instead of just coal, but the goal is exactly the same. These massive, modern power plants, they're really just giant, incredibly sophisticated kettles.
Their whole purpose is to boil water, create high-pressure steam, spin a turbine, and make electricity. The very same principle that powered the Industrial Revolution is still lighting up our world today.
So from the loud choo-choo of the locomotive to the silent hum of a modern power plant, steam has been this invisible giant carrying us forward for over 300 years. It kicked off one revolution, and it's still powering our current one. Which leaves us with a pretty big question to think about. What new engine, what new source of power is going to launch our next great leap forward? Thanks for joining me.